Good morning, dear students. Today we are going to talk about the limit test for arsenic. As I already mentioned, what is limit test? Limit test is quantitative or semi-quantitative test in order to find out the amount of impurity present in the given sample. Here the sample was arsenic. So by this procedure, we are going to determine the amount of impurities present in the given sample of arsenic, or whether our sample is pass the limiters or fail the limiters while compared with the A standard. Let's move to the principle behind the limiters for arsenic. Okay, what is arsenic? Arsenic is a highly toxic and harmful impurities present in medicinal substance and also in the pharmaceutical substance. So, this arsenic is a very harmful. So, it is very important to determine the amount of arsenic impurities present in the given sample. Okay, so here the basic principle is that this arsenic is converted into arsenic gas through the various reaction which is taken place in the apparatus. The apparatus that is known as the Gudset apparatus. For the limiters of arsenic, we are doing this limiters by an apparatus which is known as a Gudset apparatus. So, the various reactions are taken place in this Gudset apparatus, and this arsenic acid was converted into arsenic gas. And this arsenic gas react with a mercury chloride papers. This mercury chloride paper is sandwiched between the two river bunks in this Gudset apparatus, and which may be contact, this arsenic gas may be contact with this mercury chloride paper and to form an yellow stain. So here we are comparing the intensity of the yellow stain. The intensity of the yellow stain is higher, our limiters will fail when compared with the standard. So here we are comparing the intensity of the yellow stain produced by this arsenic gas while in contact with the mercury chloride paper. Next, we can move to the various reaction that was taken place in Gudset apparatus. First, we are dissolving our impurities with an acid so that this our impurity is converted into a pentavalent acid. Here we can see that a pentavalent impurities can be seen here. That is 5-valent arsenic acid has to be seen. Okay. So, we are dissolving our impurity with an acid to form a pentavalent impurity. Next step is we are using the various reducing agents like potassium iodide and stannous chloride. What is the purpose or the role of this potassium iodide or stannous chloride? That is, this pentavalent impurity is converted into trivalent. That was, these two valents has to be removed, which is reducing agent. That is, potassium iodide and stannous chloride was a reducing agent which reduce this what is reduction? Reduction is removal of oxygen. This oxygen may be removed and to converted into a trivalent arsenic acid. This was the main step that is taken place. So this pentavalent arsenic acid is converted into trivalent arsenic acid. This is known as arsenic acid. Okay. Next step, we are using two types of another reagent, that is zinc and hydrochloric acid, that is granulated zinc and hydrochloric acid. So the granulated zinc and hydrochloric acid reacted to form ZnCl plus 2H2, 2H2, that is nascent hydrogen may produce. Okay, this nascent hydrogen, next step is this nascent hydrogen reacted with our arsenious acid which was formed in the previous step. Okay, so this nascent hydrogen reacted with the arsenious acid which is formed in the previous step. So nascent hydrogen reacted with the arsenious acid to form arsen gas. This arsen gas again reacted with that mercury chloride paper. Okay, next step is the arsen gas which is formed in our previous steps has to be reacted with the mercury chloride paper. This mercury chloride paper is sandwiched between the two rubber bunks in Gudset apparatus. So this arsen gas form and which may be evaporated up and react with this mercury chloride paper and to form a brownish yellow stain on the mercury chloride paper. This yellow stain, the intensity of the yellow stain is compared with that of the standard. Here, this is the arsen gas. Arsen gas react with the HgCl2, that is mercury chloride paper, to form Hg ASH2, that is twice ASH2, that is arsenic acid to form, mercury chloride paper react with acid gas and to form an yellow stain. In this slide, we are explaining that the various types of reducing agent that we are used for the production of arsenic acid from pentavalent arsenic acid, and also we are maintaining a 40 degrees Celsius and a particular size of zinc for the control the concentration of acid and also the evolution of nascent hydrogen. And all the apparatus and all the reagents that we are used for the for this experiment should be arsenic free. Okay, next slide, we can see the Gudset apparatus. This was a Gudset apparatus. This is Gudset apparatus. All the reactions are taken place in this wide mouth bottles. Okay, this was a wide mouth bottle. Wide mouth bottle, and which has a capacity of 120 ml. 20 ml capacity ആണ്. 120 ml capacity and fitted with a rubber bunk. This is a lower rubber bunk which is fitted with a rubber bunk and also a glass tube. A small glass tube. This is a glass tube. This glass tube is fitted in this wide mouth bottle which has the diameter of 6.5 mm internal diameter and which has a length of 200 mm. This is a length has 200 mm length and also internal diameter is 6.5. This is the glass tube. This is a wide mouth bottle which have the capacity of 120 ml and a glass tube is fitted which has a length of 200 mm length and also 6.5 mm internal diameter. and a hole of 2 mm diameter is placed at the lower end. This was a hole. You can see the hole here, okay, which has a 2 mm size, and the hole produces smooth and slow passage of arsen gas. At the same time, the bottle of the tube, other end of the glass tube is fitted with the two rubber bunks. This was the other end of the glass tube is fitted with the two rubber bunks. Okay, and a mercury chloride paper. This was a mercury chloride paper. Mercury chloride paper was sandwiched. This was a mercury chloride paper. Okay, mercury chloride paper is sandwiched between the two rubber bunks. So the reaction is taken place here. The reaction is taken place here, and arsen gas produced move up and react with this mercury chloride paper and to form the yellow stain. In this slide, as I already mentioned, the apparatus consisting of a wide mouth glass bottle of 120 ml capacity fitted with a rubber bung with a glass tube of 200 mm diameter length and 6.5 mm diameter width, and a hole of 2 mm diameter at the lower end, and a hole produces smooth and slow passage of arsen gas from the bottle to the tube. The other end of the glass tube is fitted with two rubber bunks, and the mercury chloride paper is sandwiched between these two rubber bunks. The mercury chloride paper is sandwiched between these two rubber bunks, and also a cotton wool which is previously moistened with the lead acetate was placed in the glass tube. The main purpose for that is the absorption or trap of the hydrogen sulfate gas, which may be present as an impurity. And there was a side hold. During the test, the evolved gases passed through the side hole, and the lower hole serves an excess for water which contains in the constructed part of the tube. Next, move to the procedures. Okay. As an every limit test, there has to be a procedure which having two guide set apparatus. One is test and one is standard. Okay. In every limit test, we are using most of the limit tests we are using the Nessler cylinder. Here we are using the guide set apparatus as the instrument. Okay, not instrument, equipment for doing this limit test. Okay, we need two guide set apparatus. One is for standard and other is for the test. So in standard, a known amount of dilute arsenic solution is kept. Okay, in known amount, the amount of arsenic solution which has to be taken should be a known. Okay, so a known amount of dilute arsenic solution is taken in standard guide set apparatus. In test apparatus, the test solution is prepared by dissolving the specific amount of water and stannous hydrochloric acid and keep it in wide mouth bottle. That means guts and apparatus. Okay. In test, we are taking the sample solution which may be diluted with a specific amount of water and stannous hydrochloric acid. All the reagent we are using for this procedures must be arsenic free. Okay. Again, in second step, in both test and the standard, we are adding 1 gram of potassium iodide. This is potassium iodide and 5 ml of stannous chloride and 10 gram of zinc. All the reagent must be arsenic free. This potassium iodide and stannous chloride act as a reducing agent. That means the arsenic acid, pentavalent arsenic acid may be converted into arsenious acid. That was the purpose of adding potassium iodide and the stannous chloride. They act as a reducing agent. At the same time, this zinc is act as the formation of nascent hydrogen. This nascent hydrogen again reacted with the trivalent arsenious acid to form arsenic gas. So in next step, keep both the test and the standard 40 minutes aside. After that, the arsen gas formed may be evaporated up and may be reacted with this mercury chloride paper and to form the yellow stain. This was a procedure. Next, the observation. Observation means that we are comparing both the test and the standard. If our sample pass the test, we have the intensity less than that of the standard. If the yellow stain in the test is less intense than that of the standard, then the arsenic is present within the limit and the sample passes the limit test for arsenic. In second case, if this yellow stain in the test is more than that of the standard, the arsenic is present beyond the limit and fails the limit test for arsenic. This was the limit test for arsenic. So as I already mentioned, we are using Gudset apparatus for the limit test of arsenic, and the Gudset apparatus consisting of the various parts. So it is very important to study the neat labeled diagram of the Gudset apparatus and also the procedures and the principle behind the limiters of for arsenic.